Hello class, in today's lesson we're going to be looking at factorizing monic quadratic trinomials. The learning intention of this video is we're just going to quickly do a quick review on factorizing challenging DOPs. We're going to be able to identify a monic quadratic trinomial, to understand the relationship between expanding brackets to form a trinomial and factorizing a monic trinomial, to know how to factorize a monic quadratic trinomial, and lastly, to be able to simplify algebraic fractions by first factorizing and then cancelling out common factors. So what I want to do first is I want to quickly go through questions related to DOPs. In our previous lesson, I showed you how we could actually factorize DOPs by finding out what is the value of A, what is the value of B, and then substituting those values into the formula that you can see down here below. But some of the questions that I didn't show you are questions that actually have a common factor present within them. So I want to show you what do we do differently when there is a common factor present, okay? So when we have a DOP that don't have perfect squares that are obvious and they have a common factor between them, what we need to do first is we actually need to factorize the expression before we actually then apply the DOP rule, okay? So in this case over here, we can clearly say that the common factor present in this particular expression over here is going to be 12, okay? So 12 is your highest common factor. So if this is the case, we'll first factorize the expression by taking 12 outside. And if you take 12 outside, I'm therefore going to be left with y squared minus 100. And notice that after I've actually factorized this, we can clearly see nice perfect squares, since y squared is a perfect square and 100 is also a perfect square as well. So therefore, if you're trying to find out the value of a, you just go to the square root of y squared. Try to find out the value of b, that's going to be 10 in this case over here. So if you were to substitute everything back into the DOP's general formula, therefore your answer is going to be y plus 10, y minus 10, with 12 being outside on the bracket, okay? So using this example over here, have a go with answering this question over here. Give yourself 2 minutes or so and then compare your answers with my answers. Now, if you've done it successfully, what you would have recognized is that 3 is going to be the highest common factor for this particular expression. So we're going to remove 3 on the outside of the brackets. So if you did this, therefore you're going to get 3 bracket 4x squared minus 9y squared, okay? Now, we can clearly see that this over here, these are nice perfect squares. So we're going to find out what the value of a is. So therefore, to find out the value of a, just square root both sides. Therefore, if you take the square root, it's going to be 2x. To find out what the value of b is, square root 9y squared, and therefore this is going to be 3y. Once we've done this, what we're going to do is we're going to substitute the values into the general form of a DOP. So if you did this, therefore your answer is going to be 2x plus 3y, 2x minus 3y. But I also did forget to put the 3 that we've found on the outside, so that should be your final answer over here. What we're going to be looking at now is a new topic, and I'm going to be defining what a quadratic trinomial is, okay? So a quadratic trinomial is pretty much any quadratic expression or an equation that is made up of 3 terms. So tri means 3, that's a prefix for it. So any expression that consists of 3 terms, okay? And this is pretty much the standard formula of most quadratic trinomials, okay? So I've got ax squared plus bx plus c, and all this really means is that this is just an equation with 3 terms where a, b, and c represents any number. That could be 1, 2, 3. It could represent anything pretty much, okay? So we could also further categorize a trinomial as being a monic or a non-monic depending on the coefficient in front of x squared. So I'll show you what I mean by this. So on this particular flowchart over here, I've said that quadratics can be further categorized being a monic or a non-monic. Now, the word monic kind of resembles the word monos, and we know that the prefix for mono indicates 1, okay? So therefore, this is a quadratic expression where the value of a, or the number in front of x squared, is equal to 1, whereas something that's classified as non-monic is going to have a value that's any value that's different from 1, okay? So I'm just going to show you some examples. So on the left hand side over here, these 2 expressions over here are considered to be monic quadratic trinomials because they've got a 1 in front of x squared, whereas these examples over here, they have other numbers other than 1, so therefore this is considered to be non-monic. I'm now going to be looking at or discussing about factorizing quadratic trinomials. I know that we've already spent some time looking at factorizing quadratic trinomials by finding the highest common factor, by doing DOPs, as well as the grouping method. But the focus of today's lesson is looking at the other techniques that we use to actually factorize quadratic trinomials. So there are two ways you could go about it. You could either use the product sum pattern or product sum method, or you can do this by completing the square, okay? We're going to be spending today's lesson using this method. We're going to be completing the square in future lessons, all right? And just a reminder, guys, each factorizing technique can only be used under certain circumstances. Before I actually show you how we actually use the product sum method to factorize, I want to just quickly explain why do we actually factorize. And the reason why we actually factorize quadratic expressions that's in the standard form is so that it helps us locate where the x-intercepts are. So in this case over here, let's say that this over here is my quadratic equation, okay? So this contains three terms. Now in this case over here, we can clearly see on the graph that your x-intercepts is equal to 3, so x is equal to 3. We can see that this x-intercept is equal to -1. Now, if I was to factorize this guy over here, I'm not going to show you how we do it, but if I was to factorize it, this is what my equation would look like. Now, if you were to look at the relationship between the factorized form as well as your x-intercepts, you'd realize that this factorized form pretty much tells you indirectly what your x-intercepts are. This over here says a -3, your x-intercept is +3, okay? This has a +1, your x-intercept is -1. So it's pretty much the reverse or the flipped of each other over here. So that's pretty much the main thing that I want to draw your attention to. So that's the reason why we actually factorize quadratic expressions, okay? And that's pretty much summarized up here. So when a quadratic is factorized, the x-intercept is equal to the number inside the bracket with the opposite sign. So -3, and I said that's equal to a +3 over there. What I want you to do right now is I just want to get you to predict what is the x-intercepts for the following quadratic equations, okay? So these are already factorized. So based on the factorized equation, state the x-intercepts for each of these equations. Alright guys, for the very first one, you should have got x is equal to -1 as well as x is equal to -2, and I've kind of visually demonstrated that in the diagram below. For the next one, x is going to equal to +3, so it's going to be the opposite of that, and this is going to be equal to -1. And for the last one, your x-intercept is going to equal to -2, and x is going to equal to +4, and that is shown in these parabolas over here. What I want to show you now is how do we actually factorize these monic trinomials by using the product sum method, okay? So what the product sum method is, it's a factorizing technique that we use to factorize quadratic trinomials with the value of 1. So that just means we generally use this when you've got monic quadratic equations, okay? And what we're trying to do is go from the standard form. So when it's written in a similar format like this, we want to convert it into the factorized form, okay? And these squares over here, that's just where you would actually insert your numbers, okay? And what we are trying to do essentially when we're trying to use the product sum method, we're trying to find two integers, meaning two numbers, where the product is equal to c, so this over here, but it also must meet the requirement such that its sum is equal to b. Now this doesn't probably make sense to you right now, but if I show you an example, this will make a lot more sense. So let's look through the first examples of the many examples I'll be going through in today's lesson. So my equation is y is equal to x squared plus 6x plus 9, and I want it to factorize, okay? I've got the steps over here. What you want to do first is you want to list down all the factors of c. In this example over here, your c value is equal to 9. Remember that the general equation is equal to y is equal to ax squared plus bx plus c, so therefore c is equal to +9. What I do next is state all the factors. So two numbers that multiply to give you 9 is 1 and 9. Another one is going to be 3 multiplied by 3, okay? Now, the second step is I want to find a product of c such that it will equal to the sum of b. The sum of b in this example over here is 6. So b is equal to 6, okay? So therefore, what I want to do is I want to add these two together, and I'm going to add these two together, okay? So if I do this, this equals to 10 for the first one, but for my second factor pair, this is going to equal 6. Step number 3 says you want to insert the values into the squares, but you want to insert the ones where it gives you the sum of b. in this case over here, you'd agree with me that 3 and 3 multiplied together gives you 9, but when added together, that gives you 6. So therefore, we're going to be selecting these numbers over here. So therefore, we're going to be inserting those numbers in those squares, and therefore, this is going to be your actual equation. So it's going to be y is equal to bracket x plus 3, close bracket, x plus 3, close bracket. Let's have a look at another example, okay? So y is equal to x squared plus 7x plus 12. Again, I'm going to follow the same format. So I'm going to list down all the factors of c. In this example over here, c is equal to positive 12. So one of the factors is going to be 1 and 12, 2 and 6, as well as 3 and 4. Once I've listed down all the factors, I'm just going to find the sum of each of them. So therefore, 1 plus 12 equals to 13, 2 and 6 gives you 8, 3 and 4 is equal to 7. What I want to do is I want to select the factor pair that gives me the value of b. In this case, the value of b is equal to 7. So therefore, in this case over here, I'm going to be selecting this one over here, 3 and 4, because 3 times 4 gives you 12, but when added, that gives you the middle one, so 7 in this case. So therefore, all we need to do is just substitute those values directly into the squares, and therefore, this is going to be my actual answer, okay? All right, so looking at another example, okay, guys. So in this case, this is going to be a bit different because this one over here has a negative sign, but I'll show you it's pretty much the exact same process. So again, we're going to list down all the factors of c. So c in this case is equal to 24. So you've got 1 and 24. You can also have negative 1 and negative 24. You can have 2 and 12, negative 2 and negative 12. You can have 3 and 8. Negative 3 and 8, 4 and 6, as well as negative 4 and negative 6, okay? Because we're still a beginner, we're going to be listing down all the factors, but when you're a lot more fluent in this, you don't really need to show the working out in the same manner that I've done it. This is just to help you visually see how this actual method works. Again, once I've done that, I'm going to find the sum of all of these. So I've found the sum over here, but what I'm going to be doing is I'm going to choose the factor pair such that when it's added together, it's going to give me the value of b. In this case, b is equal to negative 10, so therefore I'm going to be selecting the last one. So negative 4 plus negative 6, that's going to give you negative 10. So I'm going to insert negative 4 and negative 6 into the squares. So therefore, if I insert negative 4 and negative 6, remember that a positive and negative next to each other gives you a take away or a minus sign. So therefore, that's how I've got this answer over here. And I should write y is equal to this. So that's how we actually answer this particular question. All right, guys, what I want you to do now is I want you to have a go yourself answering this question over here. So give yourself 2 minutes, use the examples that I've pretty much gone through, and then answer this question. If you guys have done this successfully, then what you should have done is you should have listed down all the factors of negative 16. So I've shown all the factors of negative 16 here. I've also showed you the sum of all the factor pairs, but we need to select the one where it adds up to positive 6. In this case of here, it's going to be negative 2 and 8. So I'm going to substitute negative 2 and 8 into the squares. Therefore, it's going to be y is equal to x minus 2x plus 8 as my final answer. And if I was to state the x-intercepts, I would state it like this. I'll state it like this if I wanted to be in a coordinate form, but either way, you could have written it as 2 and negative 8. What I want you to do for the next 15 minutes, guys, is I want you to actually answer questions 2 and 4. I know that there is a lot of questions, but because I want to get you guys to be a lot more fluent with doing this, you'll find that you'll eventually use less working out. So I want you to try to do as much as possible. So give yourself 15 minutes and then continue on to the next part of today's lesson. What we're going to be looking at now is how do we actually factorize a non-monic trinomial that does contain a common factor, okay? So the PrioritySum method can also be used if there is a common factor present in non-monic trinomials. Remember, I talked about monic trinomials being one where the value of a is equal to 1. Non-monics is where it has any value other than 1. So in this case over here, down below, I've got some non-monic expressions, okay? However, on the expressions found on the left-hand side over here, these ones over here do have a common factor, so you could actually still use the ProductSum method, whereas on the examples on the right-hand side, there's no common factors with for each of these 3 terms, so therefore you can't really use the ProductSum method for the examples shown on the right-hand side. You probably have to use a different method to actually factorize it. factorizing non-monic trinomials with a common factor pretty much works the exact same way as what we've done beforehand. But before we actually do the PrioritySum method, what you actually need to do first is you have to actually just take out the common factor before you apply the actual method, okay? So I'm going to go through an example with you guys. So I've got y is equal to 2x squared minus 10x minus 28. Now, the only thing that's different is pretty much this step over here. So what we're going to do first is factorize by taking out the highest common factor. In this case over here, you'd all agree with me that the highest common factor is going to be 2. So therefore, if since 2 is the highest common factor, I'll remove 2, put it on the outside of the brackets, and now I'm left with x squared minus 5x minus 14 within the actual brackets, okay? Now, once I've done that, what you're pretty much going to do is you're pretty much going to ignore 2 until the end and then just pretty much insert that into your answer, okay? So this is pretty much going to be like the general formula-ish when you do contain, you know, a common factor in a non-monic. So what we're going to do now is we're going to list all the factors of C. Now, when I'm talking about C, I'm not referring to the original C, which is 28. I'm talking about the one after I've actually factorized it. In this case, it's going to be negative 14, okay? So C is now negative 14. Similarly, I'm going to find out all the factors there are for negative 14. So these are all my factor pairs over here. I'm then going to find the sum of these. So therefore, I've got the sum here, but I want to choose the factor pair where it gives me the middle value, which is equal to negative 5, okay? In this case, it's going to be 2 and negative 7. So I'm going to be choosing these two, and therefore, I want to insert that into this general formula over here, okay? So therefore, if I insert that with the highest common factor that I've taken out earlier on, this is going to therefore be my final answer. Alright guys, I want you to now have a go with answering this question over here. So give yourself 2-3 minutes and then compare your answers with my answers. If you guys have done this successfully, what you should have done is taken 2 out since this is the common factor here. So therefore, it's going to be 2 bracket x squared minus x minus 6. And therefore, find all the factors of negative 6. Okay, so I've done that on the left-hand side of here. Find the sum of that. And what you want to do is you want to choose the factor pair where it gives you negative 1, because that's pretty much a 1 in front of x. So therefore, in this case, you're going to be choosing positive 2 and negative 3, and therefore you're going to be substituting that into this particular general formula here. Since 2 is a common factor, we're going to sub 2 right here, and we're going to put 2 and negative 3 into these squares over here. So therefore, this is going to be my final answer. What I want you to do right now is I want you to please answer question 3, all of question 3. So you're pretty much only just having one extra step. It shouldn't take you too long. Give yourself about 10 minutes and then move on to the next part of the lesson. What we're going to be looking at now is how do we actually simplify algebraic fractions. Now, this is pretty much very important, not so much for year 10 purposes, but definitely in year 11, year 12 maths methods, because you're going to have to deal with fractions, okay? Generally, right now, we don't really give you too much fractions to work with in year 10, but you have to be a lot more confident in year 11, year 12. So algebraic fractions can be simplified by finding common factors in the numerator and denominator and then cancelling them out, okay? And this is achieved by factorizing either your numerator, the denominator, or both. So I've got an example on the right-hand side. And what we're going to do is we're going to factorize it so that we can actually simplify it. In this case over here, I'm just going to work on the actual fraction separately. So let's just look at our numerator. We're going to factorize our numerator, okay? Now, hopefully with all the examples I've showed you, you should be able to factorize this quite readily. In this case over here, it's going to be positive 3 and negative 2, because if you multiply positive 3 and negative 2, that will give you negative 6. And if you add these two numbers, 3 take away 2, that gives you positive 1 as shown here. So that's a very quick way of double checking your answers. I can therefore factorize my denominator. So AB plus 3B, the common factor is B, so take B outside. And once you've factorized both the numerator as well as denominator, you can then start to see common factors that you can then cancel each other out. In this case over here, you've got a common binomial factor, which is A plus 3. So we can cancel these guys out over here, and therefore my final answer is going to be A minus 2 over B, okay? So that's pretty much how we actually simplify algebraic fractions. So what I want you to do now is I want you to have a go with answering these questions and then see how you go. If you guys have done this successfully, if you were to factorize your numerator, this is what your numerator would look like. Again, if you want to double check to see whether this is correct or not, you just multiply these two numbers and to see if that gives you -8, which it does in this case. And if you add -4 with +2, that will give you -2. So this is pretty much the correct factorized form. I'm also going to see if I can factorize the denominator. In this case, I can't. There's no common factor, so I'm going to write x plus 2 over here. And once I've done this, I can then cancel out x plus 2, and therefore my final answer is going to be x minus 4. Alright guys, so now I want you to please answer questions 5. This should take you about 10 minutes. This is pretty much the end of today's lesson. Hopefully you should be able to know how to use the sum product method right now to actually factorize monic quadratic expressions. We've looked at the first 4 techniques already. In the next lesson, we're going to be looking at how do we actually factorize non-monic quadratics that don't actually have a common factor present at all. Hopefully you should be able to address all 3 success criteria. Thank you for watching today's video. I'll see you guys again in the next video. Bye.